Welcome to the course on Industrial Automation and Control. Myself, Dr.M. Prasad Reddy, working as Associate Professor at Institute of Aeronautical Engineering in the Department of Electrical and Electronics Engineering. In today's lecture, I am going to discuss what are the functional elements of industrial automation systems. If you look at any industrial automation system, so it is a combination of various systems, like there will be instrumentation system, there will be sensor system, and there will be a actuator systems, and there will be a automatic control, supervisory control, production control, as well as the business and marketing strategies. So in this lecture, I am going to discuss the major functional elements of an industrial automation system. The first one is sensing and actuation elements. If you are going to automate any industry, so compulsory there will be a coordination of the various elements, like there will be a coordination between the sensors and actuators as well as the automatic control loops, and there will be a coordination or communication between the automatic and supervisory control, and in between the supervisory and also production control there will be a communication as well as the coordination. So if you want to execute any process, or if you want to come up with any final product, there will be a communication and also coordination between all these various levels of automation is required. So coming to the any automation industry, first of all, if you want to automate, compulsory you have to measure the physical variables of a process or plant or any factory. So if you want to measure any physical variable, compulsory you have to embed appropriate sensors so that you can get the data through the sensors to the next level, that is automatic control. So here the sensors are going to directly interface with the plant or process, and these sensors are going to measure the physical variables like the temperature, pressure, displacement, speed. That depends upon what kind of equipment there or what kind of variables are presented in a plant or process. And also these variables can be translated into the convenient form. So why? Because you may be going to measure the temperature, that may be converted into the resistance, or that may be converted into the like a voltage or current. That depends upon what kind of sensors you are going to place for measuring the physical variables. And the automatic control unit is going to generate the control inputs that based on whatever the data got it from the physical process. Then the control inputs converted into the physical process inputs, and again you are feeding back this particular controller input into the actuator system so that you can control the process. If you want to maintain the temperature at a certain level, first of all you need to measure the temperature through the sensors and it will be feed to the controller. Then the controller is going to generate the control input based on whatever the set point already given in the controller. Now this controller input is going to drive the actuators so that that is going to create a some motion, and further the motion will be converted into the change in the temperature. So like that, this is here sensors, actuators as well as the controllers are coordinating each other to maintain a certain level within the process or plant or factory. It may be the temperature or it may be the pressure or displacement. So if you look at the typical sensor system, so here these sensors are composed of a set of typical functional elements. So these are connected in a specified way to provide a signal in necessary form. So if you look at this particular typical sensor system, so here you have the medium, sensing element, signal conditioning element, signal processing element, and signal handling element. So what do you mean by a medium? So medium means it is a physical process where some phenomenon takes place. Suppose if you take a boiler, so there you are going to observe what is the pressure or what is the temperature takes place because of some chemical reaction or any other reactions. So there may be a change in the physical variables within the process or plant. So that is what we can say it as the medium. So now these sensing elements are going to sense this particular physical phenomena. So because of the physical phenomena, there may be a change in the physical variables, like if we are taking the temperature, So because of some physical phenomena, there will be increase or decrease in the temperature. So that particular temperature that you are going to sense through the sensing elements. So here these sensing elements are going to interact with the physical medium, either it may be directly or indirectly. Suppose if you are going to take the example as thermocouples. So what is the principle of thermocouples? So here if you are going to measure the temperature with the help of thermocouples, here one side of the junction points are interacting with the medium directly, and other side you may find out there may be a change in the voltage. So because of whatever the heat changing at the junction, because of whatever the medium physical phenomena, so you can see there will be a change in the voltage at the another end of this particular thermocouples. So that is generally here you can see the thermocouples are going to directly interact with the medium. And other side, if you are going to take the optical pyrometers, so here the second type of thing, optical pyrometers. So what is this optical pyrometers? So this also going to sense what is the temperature change takes place. How these optical pyrometers are going to sense the temperature means, so these are going to detect what is the change in the color. So if it is very much heated means you can see there is a huge amount of red color, and based on what is the color variations takes place according to the change in the temperature, that color variation is sensed indirectly through this particular optical pyrometer, and based on that particular color sensing, so we can measure the temperature of process. So by using the thermocouple, those are going to directly interact with the medium, while coming to the optical pyrometers, so these are not directly going to interact with the medium, but still those are going to measure what is the changes in the temperature by indirectly sensing what is the change in the color. So this is about the sensing elements. So here somehow you are going to sense what is the variations takes place in the medium. So now suppose if you are going to take a kind of a variety kind of sensors, so the output it may vary. So if you are going to take the thermocouples, what kind of output you are going to get here? So there will be a change in the voltage you are going to get. But if you are going to take the RTDs, what kind of output you are going to get? So that is resistance thermo detectors. So if you are going to use the RTDs for the measurement of temperature, what output you are going to get? There you are going to get the change in the resistance. Sometimes here you may get the electrical variables like the voltage and current directly, or sometimes you are going to get the change in the resistance. Then again you have to convert this particular change in the resistance to the some electrical signal. So that can be possible with the signal conditioning element. So here what you are going to do, whatever the variable you are going to sense, that can be feed to the signal conditioning element. Now when you are going to use the RTD, then you can find out the output will be a change in the resistance. Now if you are going to connect this resistance in the for any one of the arms of Wheatstone bridge, then you can find out there will be a, because of the change in the resistance, you can find out there may be a deflection in this particular Wheatstone bridge. That deflection you are going to measure. So here you are going to keep this particular change in the resistance or RTD in any one arm of the Wheatstone bridge. So like that you are going to directly get what is the form of output as electrical signal. It may be the voltage or current. Then you have the signal processing element. So here what you are going to do, so in the signal processing element you are going to perform the various activities. You may be going to filter. What is the need of filtering means? To eliminate the noise. So if there is any noise presented in the measured signals, so you have to alter the signal properties, and you have to eliminate the noise presented within the signal. So that's what you have to perform the filtering. Then diagnostics. What is the need of diagnostics here means? So if you want to know what is the health of the sensors, so whether you are going to get the data properly from the sensors or not, or whether the sensors are measuring within the given range or not. So that particular kind of information is very necessary. Why? Because if the sensors are not performing well, or if the sensors are not measuring the variables exactly, then whatever the controller actions you are going to take, so that leads to the deviation in the final product. So if you are not able to measure the data from the through the sensors from physical process, then even if you are providing the control actions to the plant, the final product variations may takes place. So that's what diagnostics also one of the important factor in the industrial sensor system. And the linearization. So here linearization means, so if there is a change in the temperature, and you need to get the output as a change in the electrical signal correspondingly. So you have to make a linear relationship between whatever the variable you are going to measure at the process and whatever the what kind of output variable you are going to get. That may be electrical, or that may be the electrical means it may be the voltage or current. So you have to make a proportional arrangement between this physical process variable and whatever the electrical signal you are going to get. So like that you are going to perform the signal processing within the sensor system. Then again you have the signal handling element. So here sometimes you have to display what is the temperature. So that may be at the next level. So usually in the industrial automation system, whatever the data you are measuring through the sensors, some part of the data may be sent to the controller units in the automatic control. So those are going to take the necessary control actions to control the plant, and in the same data may be sent to the supervisory control also. Why? Because means, so if there is a huge change in the temperature, or even you are going to provide the control inputs, but if the plant is not reaching the settling time, then again in the supervisory level you may have to take the decisions, like you can change the set point or you can change the controller. Like that it is very much useful if you are sending the data from sensors to the supervisory control. So there you may take the some decisions. And here, so signal handling element may contains display modules to display the various values, and recording and storage modules are simply feedback to a process control system. So these are the functions of this particular signal handling elements. And coming to the second element, that is the industrial actuator systems. So suppose if you are going to measure the data through the sensors from the physical medium, that will be fed to the controllers. Now what is the functioning of the controllers? So depending upon whatever the set point is given, and depending upon whatever the input you are getting from the sensors, the controller is going to generate some control inputs. So this control input has to drive some actuators. Suppose if you are going to take the flow, if you are going to control the flow of a process, now what you have to do, suppose if you have taken, this is the pipe and here you have some valve. Now you have to control what is the flow in this particular pipe. So now we have the control input here. So this control input may not drive directly this particular control valve. So now what you have to do, so why? Because this control input may be in the form of electrical signal. So now whatever the electrical signal you have, that may not drive this particular any actuators. It may be the pneumatic or it may be the hydraulic actuators. So now we have to convert this particular signal or control input into the motion, and further that particular motion is converting going to rotate this particular valve, then it is going to increase or decrease the flow within this particular pipe. So here the actuation systems are going to convert the input signals computed by the control system into forms that can be applied to the actual process and would produce the desired variations in the process physical variables. So for that purpose, we have the signal processing element here, and here we have the power amplifying element, we have the variable conversion, and we have the energy conversion element, and finally you are going to feed it to the process. So what is this signal processing element here? Now whatever the control input you are feeding to this particular signal processing element, that may contain the carrier frequencies, or that may contain the wide band of frequencies. So if you are going to feed such a kind of signal into the whatever the actuators or any other stages here, so that may lead to the saturation of that particular actuator systems. So that is not going to control the process. So that's what. So in the signal processing element, whatever the controller input you are giving into this particular industrial actuator system, that can be filtered at this particular signal processing element. Now, whatever the signal you are going to get here, that is also in the form of electrical here. So here also you are going to get the electrical form. So now you are going to amplify this particular electrical signal. So why? Because means, so whatever the controller input you have generated, that may be in terms of the millivolts or milliamps current, that may not drive this particular actuator system. So that's what you have to amplify this particular signal. How can you amplify? Means, so with the help of some power electronic devices, you have to amplify this particular signal from one level to the another level. So now here you have the low amplitude electricity signal, and here you are going to get the high power signals. So now this particular high power signals has to make a changes in the process by moving the actuators. Suppose if you are going to take, this is the valve, how we can rotate this particular valve by some 30 degrees means, so if you are going to, here you have the electrical signal, now we have to change this particular electrical signal into the some motion. So how we can create the motion means, with the help of some motors. You may take the servo motor, or you may use the stepper motor if you want to rotate by a particular angle. So depending upon what kind of requirements there, or what kind of equipment you have at the process end, accordingly you have to choose the actuator systems. So now here you are going to convert this electrical signal into some kind of motion here. So motion means it may be the linear motion, or it may be some angular motion. So that is, if you want to rotate this valve, even you can rotate by 30 degrees with the help of stepper motor. So now what is going to happen? So here you are converting the electrical variable into the some mechanical outputs. So it may be the rotation, or it may be linear motion, or it may be the angular rotation. So that is kind of mechanical outputs. So now again you have the energy conversion elements. Suppose if you are going to control what is the temperature in the process, or if you are going to control what is the steam within the process, if you are adding more water into the process, then you are going to reduce the steam within the process. Like that, based on how much water you are going to feed, you are going to control whatever the steam or whatever the temperature within the process. Again, that is going to be the energy conversion element. So this particular motion, that is going to convert into the some change in the temperature or the change in the steam level. So this is all about what is the industrial actuator sensors. So basically here, actuators are the devices so that first produce the motion from the electrical signal, which is then further converted into the other forms. In the next level, we have the industrial control system. So this is the heart of any industrial automation system. Why? Because even if you want to control any process variable, compulsory you require the controllers. And if you are looking at the industrial automation pyramid, so this is at the level 1. So this, what is the functioning of controllers? So all the time, if you have given some set point, the controllers are going to generate continuously whatever the controller inputs to maintain whatever the output is equivalent to the desired input. So whatever the command signal you have given as input, so this particular controller duty is always you have to track this particular input and output signal. So if there is any deviation between the command input and the output, then you have to make the necessary actions with the help of controller. So if the controller is not able to perform well, so he may have to change the controllers, or he may have to add some tuning techniques. So there will be a lot can be done with the controller part within the industrial automation systems. So what controllers are doing exactly? So these are the elements so that accept the command signal from the human operators or supervisory systems. So one thing, who is going to set this command reference or set point means, so either the human operators or from the supervisory control system. So you are going to get some command signal to the controllers. So that may be the acting as a command reference or set point to these particular controllers. And also you are going to get the data from the process through the sensors to the controllers. So now the controller having the two kind of inputs. One is the set point or command input that can be set or that can be given from the supervisory control or human operators. And the second input to the controller is you are going to measure what is the output from the plant that you are going to feed back to the controller. So now at this particular place, what is going to do? You are going to compare or you are going to find out is there any difference between the command input and output. So if you are going to take this particular block, so this is command input minus whatever the output, that is going to give the error signal. So now what is the input to the controller? That is the variation in the output from the input, that is what we can call it as the error. So now we are going to feed this error into the controller. So depending upon the error signal, the controller is going to generate the control input. This control input is going to drive the actuator systems, and further this actuator system is going to make a changes in the plant so that the output may be made equivalent to the input. The output is made equivalent to the input. So again, if there is any changes takes place means again you have to go back. Again the controller is going to change the controller input. That means the controller is going to continuously track the outputs, and it is going to take the control actions or generate the control actions such that the output of this particular process will be always equivalent to the given set point. So this is all about the industrial control systems. And further, if you take the control systems here within the industrial automation, so there are two kind of controllers. One is the continuous control system. So whatever the system, this is continuously tracking whatever the changes takes place in the output, that is the continuous control system. And here in the next side, you have the sequence or discrete event control actions. So here, how we are going to control the process variables means at the discrete intervals you are going to control. Why? Because if you are going to take the binary systems, there the logic will be 0 or 1. So 0 means low level, 1 means high level. So those are nothing but discrete values. So instead of continuously controlling or continuously tracking the output, here you are going to get the measure the variables at the discrete intervals. So for this particular controllers, so here you may have the on-off control, or you may have the high, medium or low level control. So here, so how we are going to sense this particular discrete variables means by using the limit switches, or by using the pressure switches, or by using the photo switch, we are going to measure whatever the process physical variables at the discrete instance. How we are going to make the controller means maybe with the help of programmable logic controllers. So these are the best suited controllers for controlling the process at the discrete intervals, and industrial PC and dedicated processor based controllers. So you may choose. And here if you are going to design such a controllers for any process for controlling, so it does not require any tuning, but it may be required in case of the continuous control system. So until and unless you are not going to change the logic, so it does not require the any tuning. So here you may get the status or sequencing or timing control. So this is about the sequence or discrete event control. And the second and the last one is supervisory control. So here what is the functioning of supervisory control? So in the supervisory control, there will be human machine interface, HMI. So where you are going to get the display of all the control or physical variables at the supervisory unit. So now, if you want to change the set point of any controller, suppose my temperature set point is 50 degrees centigrade. Now I want to increase the temperature within the boiler. So now I am going to increase my set point to the 100 degrees centigrade. How can I change the set point from 50 to 100 degrees centigrade means? So here you have to give the command input from the supervisory control to the controllers. So at the automatic control, you may be having a n number of control loops. All these control loops are monitored by the supervisory control. This supervisory control is providing the command inputs to the all control loops that are presented in the automatic control. So here set point computations, so that is going to show the impact on energy, quality and also production volume. Suppose if you have changed the 50 to 100 degrees centigrade, so if the settling time is very much high, then you cannot save the energy and also you cannot make the production volume increase. So in that case, you have to change the controller so that you have to minimize the settling time so that you can minimize the energy as well as you can increase the production volume. So this and all related to the supervisory control. And also at the supervisory control, you may take some decisions. If you want to start up the process or if you want to shut down, and if there is any emergency operations that can be performed at the supervisory control level. And also control reconfiguration or tuning. So if the control is not performing well, then you may have to change the controller or you may have to adopt the new tuning techniques. And performance monitoring and diagnostics. So if there is any deviation takes place or large deviations takes place within the variables, then compulsory you have to perform the diagnostics. So some part of the data of sensors that may be processed to the supervisory control. So there you can perform the monitoring of these particular physical variables and also you can perform the diagnostics. And operator interface. So there will be a human machine interface or displays that will be presented in the supervisory level. There the human operator can have a picturized values of all these particular process variables. So domain dependent. So this is the physical model based, and even you can work in the hard or soft real time. So if you go to any supervisory control input, so it is a combination of both hardware or software equipments. So there you have some dedicated hardware equipment and also you have the dedicated software at the supervisory level for controlling the industrial automation process. And you have the production control. So this is at the level 3 of industrial automation pyramid. So here you are going to perform the process scheduling and material handling, maintenance management, inventory management, quality management, resource optimization and technology. So at the production level, you may be having the a variety of tools to perform scheduling, maintenance, management, quality control and also optimization. So here you are going to run a numerous amount of tools that are specifically related to the what kind of automation system you are going to use. So based on that one, you are going to make the changes in the supervisory control. And the another last one is at the level 4. So there you are going to control at the enterprise level. So that is completely related to the business aspects. So these are the various elements of industrial automation system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.